so good morning, good afternoon, and good very early morning for our speakers today. My name is Jesse. I'm your virtual adventure guide here with Exploring by the Seat of Your Pants. And if you're joining us for the first time today, we are all about bringing conservation, adventure, and science into classrooms around the world. And I'm so excited of all days that you're joining us today because today is World Oceans Day. We've been celebrating June 8th for 7 years now as an organization. We always do a huge blitz of events, and this year is no different with 21 broadcasts this week alone. I just never stop hanging out at the computer, and it's been a huge ton of fun as we've had the chance to feature some of the coolest scientists and explorers from around planet Earth. Now, even amidst the broadcasts we've done, and I must say they've all been pretty spectacular, they're all on our YouTube channel, I really am excited about today's broadcast because we are joining live again with the EV Nautilus, the Ocean Exploration Trust exploration vessel Nautilus. And we have done 20 plus programs with them over the last few years. They are the leading research ship in the world at exploring unmapped, uncharted parts of the ocean. And better than that, for our purposes, they are the best group on planet Earth at sharing the magic and wonder of ocean exploration with classrooms like you. So as befits such a great group, we have a huge audience from all across the continent and beyond today. I'm so excited for you all to be here. And without further ado, I'm going to bring in our friends at the Nautilus to tell us a little bit about where they are, what they're doing, and what's going on in this amazing expedition. Thanks for joining us, you two, and welcome to the program.
Well, good morning, everybody. We are so welcome to be talking to y'all guys. We're so excited. It is 4 a.m. in the morning here. And sadly, today we are not quite in the water yet. If you would have tuned in yesterday, we were right in the middle of an epic deep dive. We're right at the tail end of the dive. We saw some of the most massive, beautiful corals that you can ever imagine. So before we go any further, let me introduce myself. My name is Katie Doyle. I'm a lead science communication fellow aboard EV Nautilus.
And good morning, everyone. I'm Brian Kennedy. I am the biological sciences lead and watch lead for the 4 to 8. And when I'm on shore, I'm the chief scientist for the Ocean Discovery League and an affiliate researcher at Boston University, and I study deep sea benthic ecology.
Awesome. Thank you so much. So let me show y'all guys where we are exactly. So y'all guys could probably recognize here's the United States. But if you keep going and going and going and going, you are going to get right out into the middle of the Pacific Ocean. So right up here at the top, you might be able to recognize the little bit of the Hawaiian island chain. So we left Hawaii, I guess, what was it, about 23 days now? Oh my gosh. And so we took about 4 days and we traveled just kind of due south. And we're out here in this area somewhere. And so if you go further down, you're going to see Kingman Reef and Palmyra Atoll. And we're out here and exploring unnamed geodes, unnamed seamounts. And I'm not sure, Brian, are we still inside the EEZ right now?
Yep. So we're still in the exclusive economic zone of the United States around Kingman and Palmyra. It's one of the unaffiliated, uninhabited U.S. territories in the Pacific. We're about 180 miles northeast of Kingman and Palmyra right now, right on the edge of the U.S. exclusive economic zone and international waters, or the high seas.
Awesome. Well, thank you so much. So what, in your opinion, what have been some of the highlights for you?
So I study corals, and so what really gets me excited are these really high density, high abundance communities of corals, and we've seen 2 of those so far this expedition, which is pretty good. One was last night. We saw a beautiful group of really tall, probably 1,000-plus-year-old, what we call bamboo corals, and 2 or 3 species. We got up to the summit of this one ridge type seamount, and the whole summit was just covered with these massive, ancient corals, taller than the ROV. The ROV is, maybe about the size of a car, and we were looking up at some of these corals. They were just amazing. And we had another experience similar to that about a week ago on the summit of another feature, a geotype seamount, but it was a totally different group of species. So we fought 2 of these high density communities, and they had completely different community compositions and community dynamics, which is what I study. So I'm really fascinated out here about seeing these communities and understanding why in some places you have all bamboo corals and the other places you have all hemicoralliums and chrysogorgids and all these other beautiful corals. So it's been a really great expedition for me, and I'm sorry that we're starting to wrap up and only have 1 or 2 more dives left.
Well, so you hit on something really important, which is how does the geology and the biology go together? So one of the things that you have been studying so much and that this expedition has really been looking at is the geology. And so will you tell us a little bit about the geology of this area, if
Yeah,
you can?
absolutely. So the the Line Islands come from basically a volcanic hotspot, just like the Hawaiian Islands, and so you get this long linear chain of islands. And so out here you have two different rock types. You've got basalts and gabbros that come from like a shield volcano, and then you've got carbonates and things like that that grow on top of these features while their islands are in the shallow waters. And so we've really been trying to help our geology colleagues understand the formation of this hotspot. So what you're looking at here is basically pillow basalts. So these are formed about 100 to 120 million years ago when this area was over the mantle hotspot plume. And these roll out and they cool really quickly, making these lobate or rounded shapes. And over the last 100 million years, they have grown a new rock that grows out of the water, precipitates out of the water, called ferromanganese crust. And so all of that black you're seeing with that bumpy texture is actually rock that's grown from seawater, encrusting over the rock from the original volcano. So we're studying both the crust, because there's a lot of interest in deep sea mining and understanding what's in those crusts, what the concentrations are, and things like that. And then we're also studying the volcanic origin rock, the igneous rock in the middle, to help us understand plate tectonics and volcanic formation and stuff in this area.
Yeah, and so like you were talking about, we've been looking a lot at the crust around that. And so with this ferromanganese, that black layer, this accrues really, really slowly, right?
Yeah, something on the order of 1 to 10 millimeters per million years. So when you
Wow.
see a crust, though, that black band on the outside of that rock is the crust that's precipitated out of the seawater, and that grayer color is the original volcanic rock. So if you look at that crust being 5 or 6 centimeters across, that turns into many, many tens of millions of years.
But we're not just seeing volcanic rock, right? We're also seeing some carbonate rock.
Yep, unquestionably. So in the shallows, when a seamount reaches the surface and turns into an island, it starts growing corals. And then as it subsides and shrinks and erodes, the corals keep growing. So they grow this carbonate cap out of their skeletons, basically, on the top of these features. And then as the seamounts sink deeper and deeper, eventually they drown the reef, but they still have these carbonate caps, like the rock you were just looking at here, that's made out of old sand and old coral skeletons, just like you'd find on the beach in Hawaii. But these are now 1,000 meters plus underwater because the seamounts have subsided and eroded down.
And so we've been doing a lot of work on some different seamounts. In fact, I actually have a picture of one of our previous dives. Will you talk a little bit about a geo versus a seamount and kind of how do we plan our dives going up these?
Yeah, certainly. So geos or flat top seamounts or table mounts, and these are what we expect has happened here is they were islands at some point and they eroded the top off, and so they're very, very flat on the top. As of like a more standard conical shaped seamount, just looks like an underwater mountain. But here you can see that zigzaggy line moving up the flank of this geo. Is we landed here about 2,500 meters, and then worked uphill trying to find the steeper slopes because they're more likely to have exposed rocks where corals and sponges like to live, as well as have areas we can collect rocks. And so this dive would have taken us about 20 to 24 hours to get up that course. And then we try and get up on the summit and see that transition from the flank of the seamount up to the top. And then me personally, I'm interested in understanding the species turnover with depth, where we see some species, where we see different communities, how that varies with slope of the seamount, how that varies with the depth, how that varies with water column properties like dissolved oxygen. But one thing you should really note looking at this picture is it's like hiking up a mountain at night with a flashlight, trying to understand the entire mountain. We're going up with Hercules covering a few kilometers in a day and only being able to see, 10 meters or 30 feet or so around the vehicle at any point, and trying to infer what the entire seamount community is like based on one or two of these kind of hikes with a flashlight up the side of these features. So even when a seamount has quote unquote been explored by modern standards, meaning like 2 or 3 ROV dives on it, we've still got thousands of square kilometers on a single, group of features that we really still haven't seen or documented that may and have a different and new life that we haven't seen yet.
So, and that brings up a good point is finding all these different creatures. And we already kind of hit a little bit about on that, which is the geology affects the biology. And this is what you mainly study is how does the geology and the biology relate? What makes the entire ecosystem? So I want to show y'all guys online a little bit of some of the organisms that we've seen down here. And one of them that has absolutely kind of been my favorite, just because it shows you so much diversity, is this picture right here. And in this photo, we have several different organisms. And will you explain a little bit about what you, as a scientist, as a benthic ecologist, see when you see this photo, Brian?
Certainly. So the first thing I see is the importance of deep sea corals as habitat or ecosystem engineers. So the pink you're seeing in there is a coral called Paragorgia, or also known as a bubblegum coral. And it grows, it's an octocoral, like if you've ever been scuba diving and seen the big sea fans in the shallows, those are gorgonians, and this is also a type of gorgonian. And so it makes this habitat. It grows a skeleton that comes up in the water, gets up in the current flow, and then it can play host for numerous other organisms. So these bigger, fatter polyps you see here are actually zoanthids, and so they're still a type of anthozoan or a close relative to a coral, but they don't grow a skeleton, and they live on other coral skeletons. So you see this is about half Paragorgia pink and about half red Paragorgia and kind of light pink white zoanthid. And then you see down here in these arms, you can see here, here, and here, those are actually brittle stars or ophiuroids that also hang out in the coral, use the coral as structure to get up off the bottom. And then this green mass here, kind of center left, we believe is a cephalopod or octopus egg case. And so these things also are nurseries for other mobile fauna. So we really wouldn't see anything nearly as complex to this community without the underlying Paragorgia coral here making it. So this is a really cool example of ecosystem engineering in the deep sea by these corals, which makes them so important.
And that was when we first came across that green thing. I wanted to say, "Bless you, coral," because I thought somebody had like wiped their nose or something on the coral. And then to find out that that's actually possibly a cephalopod egg, um, has just been absolutely astonishing to me. Now, we have not seen any cephalopods this expedition.
Surprisingly, no.
Yeah. And that's something that you were saying is very surprising for this area. We should be seeing a much more, or we should see a higher abundance. But then that brings into question, or it makes us look and evaluate, how are we collecting? So we use two ROVs, which can sometimes be very bright and very loud, but that's how we're doing our exploration. And that's the common system right now, is to either use one ROV or remotely operated vehicle, or to use two. Will you tell us a little bit about our tandem ROV system?
Yeah, certainly. So it's a two-body system, as Katie alluded to. The primary ROV that's kind of, I guess, the most famous is Hercules. It's the one that goes and stays down near the bottom, and we get the really, really high resolution imagery from Hercules. And then we also have a second vehicle down there. In this case, we're using Atalanta. If you watched Nautilus Live before, you may have seen Argus. Atalanta's a little bit lighter in this part of the world, so that's Atalanta. And the signal comes up from both vehicles by a 6/8 armored fiber optic cable, gets to the ship, and then we beam the signals to a geosynchronous satellite and then back down to Earth, and that allows us to talk to you like we're doing right now. And that two-body ROV system is really nice because we get to look at the bottom and have kind of an eye in the sky from Atlanta to get a better sense of the shape of the seafloor, what's around the vehicle, and it helps the pilots fly because they kind of have an eye in the sky that can see what's behind them.
Yeah, that's and this photo right here, I think, does a great job of illustrating the purpose of that second ROV, the purpose of Atalanta, or in previous seasons, so many times we used Argus, where Argus, or in this case, this expedition, Atalanta, is able to keep that bird's eye view on Hercules, allowing Hercules to go in some sometimes kind of interesting situations, as you can see here. Now, this was not from this expedition, but I just like this photo to illustrate Hercules able to do some more interesting dives because of having that second ROV, because of having Atalanta as that eye in the sky kind of instrument. So we've seen some really interesting organisms. Brian, do you happen to have a favorite of one of the organisms that we've seen so far?
One of the things I think the most is this little Narcomedusa jellyfish that we saw a couple dives ago. So this is a really strange observation on a couple fold. What we think it is, we're sure it's a new species. Well, the genus we think it is has only been seen one other time. It was actually on an expedition I led to Johnston Atoll, which is out a neighbor of where we are now. In 2015, we documented this coral jellyfish, and then we're seeing it twice on this expedition now. But this one's even particularly weird because normally it has 4 tentacles. This one had 3. and we're still kind of puzzling over what happened to the extra tentacle, because this is still a very symmetric jellyfish and whatnot. So we think currently it was probably attacked when it was a little jellyfish, and part of its bell and lost a tentacle, and then it just healed cleanly. But we've been working with a group of experts at JAMSTEC, which is the Japanese Meteorological and Oceanographical governance and regulatory agency, and they have probably the premier expert on jellyfish in the Pacific. And so Dougal Lindsay over there has been consulting with us, trying to identify this, and it's unquestionably a new species. And like I said, it's only been seen once or twice anywhere before. And so Dougal was super, super excited when we started sending him the pictures of our 2 encounters with that so far.
Yeah. So I want to toss this back over to y'all guys. We have been talking for quite a bit of time. I want to know, do y'all have any questions for us? What would y'all like to learn more about?
Well, our YouTube clouds, if you guys want to chime in the chat, we'd love to hear from you. I must say, I could go all day just in that cool blue jellyfish, but that is the freakiest thing I've seen in quite some time. New species questions have been pervasive this Oceans Week. Every single broadcast we do, when you go to the ocean, do you find new species? And the answer is yes, every time. You guys as communicators and scientists know this, that it's so little explored that every time we look, we find new ecosystems, habitats, agglomerations of creatures in just the coolest way. It must be so special every morning to wake up and get a chance to see what's been discovered. That is so, so cool. Let's head to our classes. As you said, I want to dive in with questions. Mr. McGill's class joining us in Thunder Bay. I'm going to head to you guys first if you want to come on in. Room 9, Kinders, Mr. Shaddix, I'm coming to all you in a sec. But Mr. McGill, welcome in, guys. Hey.
1 second, yeah.
Take your time. Nice to have you in today, everyone. Hey, man.
How do you tell the age
Good
of
morning.
Say again.
How do you tell the age of a coral?
So there's a couple different ways, and it varies greatly. So some of these more proteinaceous skeletons, meaning the ones the gorgonians that kind of flap in the wind, are really hard because they continue to grow and change their they grow and shed skin just like we do, and so it's hard to get a piece of it that's truly old. So some of it we're inferring. Some of the harder corals, the sclerotinians, the hemicoralliums, things like that, they lay down tree rings in some, or lay down rings similar to trees. And so if you drill through the base, the thickest part of its skeleton, you can do some radioisotope dating, carbon-14, carbon-15 ratio dating. And the oldest coral ever dated was 4,400 years old, and it was found in the Northwest Hawaiian Islands in the Papahanaumokuakea Marine National Monument.
Wow.
Great
that was
pronunciation, by the
awesome.
way. That not only is very cool science, but you nailed that like first try. Way to go. Guys, I'm so glad we got that question. I was going to ask that if one of our classes didn't. You kicked it off with it. So thanks, Mr. McGill's class. Room 9 crew, I'm going to head to you guys. Come on in with a question. Hey.
Has global warming affected coral growth?
Yeah, has global warming affected coral growth? Good question.
Excellent question.
Yeah, in shallow water, it's affecting it, and it has a massive effect. Shallow water corals live right at their upper thermal tolerance. They live in water as hot as they can live already. So as soon as the water starts to get a little bit hotter, shallow water coral has a really hard time. Deep water coral and deep water ecosystems, frankly, we know so little about them that documenting the change is really, really difficult. We're in the process of really making the first observations down here, getting a baseline in which we can compare change to. So really, we're playing catch up when it comes to climate change, and we're trying to make our baseline at the same time we expect things to already be changing. So we're definitely sure that it will change down here through ocean acidification, increasing size of oxygen minimum zones, increasing temperature, decreasing current flow. All of these global ramifications of climate change will and are affecting the deep sea. But it's hard for us to really quantify that effect right now on the life because we just have so little data over such a short period of time.
I really appreciate that nuance with this very unique ecosystem that you're covering, because as our students will know, universally, universally, every habitat we talk about, if people ask if climate change is affecting it, the answer is an enthusiastic yes. And so you're in this unique position of exploring a place in a new way for the first time as you're seeing the changes you said. So I'm really glad we got that question. Thanks, Room 9. Ms. LaRusso's class, if you guys want to unmute your mic, I can come to you in a minute, but we'll head to Carter and Mr. Shaddix's class first. Come on in, guys. Hey, Carter.
You still remember me. That's a good thing. Very good thing. What made you interested in all this stuff?
Want to take
Ooh.
this one first?
Yeah. So I have always been interested in the ocean and been interested in the deep sea. And so when I was growing up, I got to help out on a crab boat out of the Gulf of Mexico, which is where I'm from. And ever since then, I've wanted to explore and know more about the ocean. So my career path is kind of lily padded every which way. And then it's led me to my path here, which has been absolutely extraordinary, getting to see all the amazing, unique creatures down here in the deep sea. And especially for me, because I'm so used to working in shallow water habitats like the coastal areas around the Gulf of Mexico. Great
Yeah,
question.
for me, when I was on a family vacation when I was 5 years old, we found a manatee, and I was apparently
Whoa.
fascinated by it. And the family legend is that the light bulb went off over my head, and I announced I wanted to be a marine biologist on the car ride home, and never looked back. I've bounced around different things: shallow water coral, deep water coral, a little bit of work on with cetaceans and whales, but always some kind of marine science or marine technology.
And before we toss it back, you bring up a really good point that we didn't talk about earlier. We have actually found several fossilized whale bones on this expedition. So you're looking at right now one of the fossilized whale bones that we have found, and we found, what is it,
Four now, yeah.
four of them. We thought we found a fifth, but it turns out it was a sponge stalk that had just gotten encrusted with this ferromanganese. So we believe that this is possibly the rostrum, or kind of like the nose portion of the skull, for a beaked whale. And so now we have several of these whale fossils in our lab, our wet lab down at the bottom of the boat. Let me see if I can pull that up for y'all guys real quick.
Please.
So this is our wet lab. This is where we're processing our samples. And you can see several of those rocks in there. We can see our microscope in the back. In our deep sea freezers, you can see sand samples. Over here, we have our living tissue samples, or our biological tissue samples. And then somewhere over there, it was here on this first one, but I see the rocks have kind of moved it out. But somewhere over here, there are our whale fossils. And so we're going to send those back to a couple of different places. I know one of them is going to be Harvard, to kind of analyze this and tell us more about this whale fossil, or these whale fossils, plural.
Cool.
So I'm so glad that you brought that up.
Yeah. By the way, beaked whales in general are such a rare group. It's even rare for me to hear the name beaked whale in our broadcast. We feature a lot of marine biologists. How do you, out of a quick follow-up personally, how do you know it's a fossil when you're looking at it from afar as opposed to a more recent bone? Like, how do you know it's been fossilized from, yeah.
So in this case, it's the ferromanganese crust. As I talked about earlier, it takes millions of years to deposit any of this. So the fact that these are black encrusted, it's the equivalent of fossilization in the deep sea. You don't get the same level of mineral replacements you do when it's just sitting in the water that you would if it's buried in sand on land. But that ferromanganese crust really what crosses the line in the deep sea.
Very, very
Yeah,
cool.
that was.
Oh, just tell me to be quiet.
No, you're good.
I'm too excited. You can just get me to leave anytime. We got a great question online from Miss Yip's class joining us in Houston. So nice to have a texting class in today. So they want to know about the different, literally, paths to sea, paths to career opportunities on something like the EV Nautilus. Her kids, like a lot of kids in our broadcast, think you have to be a biologist, you have to be a volcano expert. If you're not a professional scientist, what are opportunities for you on board something like the Nautilus?
Ooh, that's a great one. And I'm so glad that y'all are bringing that up. Thank you, Houston. There's so many different career paths out here. You do not have to be a biologist. You don't have to be a geologist. You can be so many different things. One of them is you can be an ROV technician. You could be piloting the ROVs, an electrical engineer, somebody that works on the ROVs. This is an excellent career path. Not only that, but in case maybe robotics aren't your thing, also, we have data engineers who keep all of the electronics running. We have video engineers who make sure that we get the highest quality videos that you could see. We also have 2 chefs on board, and we have a full-time ship's crew on board that makes sure that the boat's going where it needs to be going. So many different career roles, so many different paths to coming out on the Nautilus. And there's not just one set role, so many different ways.
Yeah, I think there are 50 people on the ship, and I think 4 of us have PhDs. 3 or 4 others are working on grad school, and the other 40 aren't science or highly academically trained past like master's level engineering kind of thing. Yeah. So it's definitely the majority of the people out here are not PhD level scientists.
Yep. I love that this is a question that we get. Again, we're in an ocean context today, whether it's Arctic, whether it's space. I mean, if you're interested in science and nature and exploration, there's so many roles for you. And I mean, you highlighted so many, which is spectacular. But I love harping on this message for all our classrooms. And I will say at the beginning, I said you guys are the best at doing outreach to the public. That was the slickest deconstruction of an ROV video I've ever seen, and actually probably exists in the world. So thank you for bringing that into the program. That was very cool. Live classes, I'm coming back for another round with all of you. YouTubers, feel free to keep chiming in. We've got like tons of time for a Q&A here, which is great. So Mr. McGill's class, I'll head back to Thunder Bay. Come on in. Hey.
How much does Hercules cost to build? Have there ever been any major problems with Hercules?
Yeah,
Ooh.
so Hercules is about 20 years old now, and I don't remember the initial cost, but replacement cost would be in the $3 to $5 million range to build a new one. And you know, ROVs are custom. These type of ROVs are all custom one-off builds. You can buy some deep sea ROVs kind of off the shelf, but for a science class ROV like Hercules, they're almost always custom built and tailored for a specific ship and use. And over the 20 years, absolutely, there have been plenty of major problems with it. Anytime you put high voltage metal that rust in a corrosive, electrically conductive fluid and then pressurize it to 6,000 pounds per square inch, there's going to be problems. And that's just kind of the nature of doing this type of extremely difficult deep sea work. Is there's always something a little bit wrong that needs to be maintenance or whatever. It's a full-time job. As soon as the ROV comes on deck, you know, a whole team of technicians and engineers to send on the vehicle to do preventative maintenance, fix all the little problems that have to be fixed, and get ahead of the little problems that they think are coming up. Then every once in a while, sometimes you get behind the curve and you get a major problem and it keeps you out of the water for a day or two while they have to fix it.
Yeah, that is a fantastic point. And just this past summer, over the winter, so when we weren't out exploring, Hercules got an entirely new frame. So think about like the frame of your car, and attached to it is your engine, your steering wheel, your seats, catalytic converters, all those different things. So they had to go in and take kind of everything off, replace the frame, so replace the main body, and then kind of put everything back on. And one of the things that they put back on this new frame is its light bar. So that big front of the Hercules. Let me see if I can pull up a cool view of that. Not the best view, but a brand new light bar at the front, and you can kind of see its frame right here. This is something that they put on just this winter. So always in the process of upgrading, always in the process of making sure that we have the best technology to go explore the deep sea. Excellent question.
It is. It's been really interesting for me getting to see how kids over the last couple of years, especially, have highlighted the cost of things. And I always like to highlight that comparatively in US, Canadian, worldwide science budgets and exploration, it's about 1.5 to 3.5% of budgets worldwide. And so much is done with that relatively small piece of the pie to explore and understand the world and cosmos around us, which is just gobsmacking to me that we can do so much with relatively so little. So thank you for that question, guys. Room 9, come on in. Take us away with another question. Our kinder class, I'd still love to hear from you guys in the chat. Don't be shy. But room 9, you're good to go. Hey. Well, what kind of sharks live in the area? Great question.
Yeah, so there's in the deep sea, probably the most common deep shark we see around here is a six-gill shark. And so this shark that Katie's going to put up here in just a second is a blunt nose six-gill shark. It's about 12 feet or 3 or 4 meters long. And these are pretty common. These are probably the most common of the big deep sea sharks. We haven't seen any this big yet this expedition, but we've been seeing a lot of these smaller, like half-meter, 1 to 2 foot black dogfish out here, a fair amount, and that's in the deep. But on in the shallow water, the really most common sharks we see around here are oceanic white tips, and so these are attracted to waters or things that float on the surface. So every time we park the ship and hang out for the day while the ROV's diving, we congregate a big school of these, sometimes 5, 6 of these sharks will just hang out under the ship all day long. And here's a good picture from Hercules during one of the recoveries recently. We can see 4 of these oceanic white tips just hanging out with us all day while we're diving much deeper with the ROVs.
And can you tell the viewers online, why are they hanging out with us?
That's one of those scientific questions we don't have an answer to. There's a tendency of deep water or in deep water fish, any kind of thing floating on the surface aggregates them. We call them fish aggregating devices when they're intentionally designed to do that. But basically, you throw any piece of flotsam, jetsam, or a ship out there, and you're gonna and leave it, sitting still for a while, and you're gonna start aggregating fish of all types: sharks, mahi, tuna, little things coming up. So here's some mahi that swam by the ROV recently, and so it's kind of fun for the biologist, even when we're off watch, to just sit on the ship and look in the water and start watching these aggregations build around the ship as we hang out, holding station over the ROV.
And Brian, before we switch back, you were saying that we're seeing some littler sharks down at the bottom. Can you tell us a little bit about those kind of little sharks down there? And I say little, but it's all relatively speaking.
Sure. So this is a black dogfish. It's in the same family as lantern sharks, if you've ever seen that. They have little bioluminescent things around their eyes, and they are kind of what we call a mesopredator down here, where they're in the middle of the food chain. They eat smaller fish, but bigger fish eat them. And so these have been a pretty common occurrence throughout the expedition.
Yeah, and so you said that this guy bioluminesces. Can we capture the bioluminescence? Because we get that question about every night in SPL. Can we capture any of that bioluminescence on our side?
No, not really. The cameras we use are optimized for really tight zooms, but in really good light. And if you take the light off enough to not drown out the bioluminescence down here, our cameras on Hercules are not sensitive enough to pick it up. But there are certainly cameras that are sensitive enough. We just don't happen to have one.
Yeah. Very, very cool. Thank you for all that. And by the way, for our classes that are keen to learn more, one of my favorite pieces of footage ever, if you go to Blue Planet 2, which is the best documentary ever made, the deep sea episode has a whale fall. So an example of where a whale has died and gone to the bottom, and you have these six-gill sharks and all these cool creatures that live in the deep sea going to take a bite out of it. So I encourage you to check that out on YouTube and beyond. Mr. Shattuck's class, we're going to head back to you guys, take a few more from YouTube, and then time flies and you're having fun, folks. We'll wrap up the broadcast not long after that, but I'll make sure all our classes have resources to keep the learning going. Mr. Shattuck, welcome in, guys.
Hi. If the Earth continues to warm up, would at some point the water all dry out?
No.
Ooh.
The short answer for that is no. So as the water, as the Earth warms, evaporation will increase, and so more water will come out of liquid form into the atmosphere. But you'll just get more rain. It'll get up to the top of the atmosphere. It'll cool down. It'll move to a different latitude where it's cooler and fall down. So we'll end up with more torrential rain in certain areas and more droughts in another as you increase the temperature in the atmosphere. But it will certainly just speed up the hydrologic cycle of water evaporating and raining and then flowing downhill and then evaporating again. Will just get more intense and faster. But it will continue.
And Jesse, if you don't mind, before we switch it back over to you, you were talking about a really cool whale fall. So
Yes.
on this expedition earlier, we found some kind of a predator fall. We're not sure what kind. I don't have a clip of that, but I do have a clip of a whale fall that we found a couple of years ago off the coast of California. And so you can see that large whale back there, definitely a baleen whale. And Brian, you're definitely the biologist. What do you see when you look at these images?
So I see, first off, you said it's a baleen whale, and you can tell by the shape of its head that it is baleen whale. And I see a pretty advanced whale fall, actually. Most of the tissue is gone, so we're in a later succession stage. So one of the cool things about whale falls is how closely timed the community ecology changes, and you get multiple communities that are completely different feeding on this, from the initial scavengers like the big sharks to these kind of secondary scavengers, all these rat tail fish and octopuses here, and then you move into more of even a chemical finer grain where you have Ossidex bone-eating worms that'll start digesting the bones. You'll have and then you'll get a chemosynthetic community that actually exists to help break down the really recalcitrant parts of the bones and things like that are harder to decompose, and then eventually there'll just be a microbial mat left after the entire whale is been dissolved, but that can take, years to decades in the deep sea because everything kind of moves a little bit on a slower pace.
And so as y'all guys are watching this video, y'all guys might have seen those two lasers down there. And those two lasers are 10 centimeters apart, and they can help us kind of determine how big an animal is. So there they are. There are those two lasers. So 10 centimeters apart, and they're just slowly going up and down. And we can get a good estimate of what's the size of the creatures down there, what's the size of the whale, and just, again, a better determination of what the size is.
That is amazing. I was going to follow up with a laser question, and I will note two other things. First of all, it's the first time I've ever heard the word recalcitrant. I've only ever seen it written, so thank you for that. And secondly, the view from the one ROV, looking at the other one, looking at the whale falls, one of the coolest pictures ever. That should be the cover of all your outreach, really. That is pretty metal. I'm going to take one more from YouTube. Miss Ship's Class has a great question for us today. What data is being collected on this expedition that isn't reliant on these ROVs? Any sensors deployed on ropes or samples scooped from surface waters? How are you collecting everything you're learning?
Ooh.
Yeah, so everything we're collecting from the seafloor is coming from the ROVs, but we're using several different modes of acoustic remote sensing or sonars to study the deep sea. So our primary sensor for that is our hull-mounted multi-beam sonar. And so basically we drive around, we make a really loud sound, and then we time how long till we hear the echo come back, and we can calculate the speed of sound in water and infer how far away the bottom is from the ship. That's the really simplistic form. If you get into the engineering, the math behind the way these sonars actually work and the signal processing blows my mind. We actually make one noise and then count 800 different echoes from the same noise and at different angles and measure the phase shift of everything. And it really, the physics behind this is just silly and how awesome it is, but it's way beyond me. But this is a great example of what it looks like when we have satellite-based bathymetric altimeter, which that way that kind of just amorphous blob you just saw, and then this is what the same feature looked like after we mapped it with a really nice flat top geo here. That's our primary sonar. We also have a sonar that's able to look into the seafloor and look at the different sediment layers beneath the seafloor. We have another sonar that allows us to really in detail study the motion of the water. So it uses the Doppler effect to bounce sound off little plankton particles in the water and tell which way they're going, that we can measure the direction and speed of water currents at multiple layers in the water. So we have a whole suite of acoustic hull-mounted sonars that give us a better picture of the ecosystem in general operating in the water above the sea floor. And when we think about mapping broadly, this is something that's really important to get a better sense of maps in the deep sea. There's an effort called Seabed 2030 to map the entire world's oceans by the year 2030. And we're about 22% is the last time the organization running that kind of updated. So we've got a long, long way to go in the next 7 years. But this is a shot of the Pacific with all the high resolution multi-beam bathymetry. And you see all that black area is areas of the ocean that hasn't been mapped to modern standards.
And before we switch it back, I want to show y'all guys what it looks like as we're mapping live. So you can see our data coming in live. And just like Brian was saying, we're using our multi-beam echo sounder. It's coming down here. It's striking the bottom. You can see kind of this fan. And a good way to think about this also is a flashlight. When you take a flashlight and you're shining it at the ground, when you get really, really close to the ground, the light gets kind of narrower. And then as you move away from the ground, the light kind of spreads out in more of a fan. And so the areas that are coming up here in red are going to be a little bit shallower. We don't see really in blue or dark purple, which means that it would be very deep. So we still are deep, about 2,000 meters, 2,049 meters. And then down here on the side, this is going to be where we're able to see kind of what the bottom layer is, right? That deep sea kind of showing if it's coral, if it's mud, if it's hard rock. And that's kind of the other part of mapping. What's on the bottom? Is it soft? Is it hard? Is it coral? Is it volcanic lava or old volcanic lava? That was a great question.
Great question and great answer. I'll tell our students, if you can find anything in your life that you are as passionate as these two are about deep sea exploration, you are set. I mean, it doesn't matter if it's art, history, whatever. Just if you can do a 5-minute answer and not blink with just sheer excitement, that's a very good sign. So thank you two for your incredible passion, especially as early in the morning as it is. I will note again, if people want to learn more about the amazing work that you guys are doing on these expeditions, not only are we doing another broadcast with you in just a couple of weeks, but check out nautiluslive.org. There is no better site on this planet for highlighting an active research expedition than this. I would have died to have this when I was a kid, and so you guys can leave this broadcast right now. You can skip math. You can go later today and just check out live feeds and all sorts of amazing information of what they're discovering on the Nautilus ship. It is such a cool tool to explore with. For you two, before we bring in all our classes to join me in saying a big thank you and farewell, is there any final message you want to share with our kids about this expedition or about the Nautilus generally?
I would just like to say we're going to be diving again at around 8:30 our time. So if it's around 3:30, 3:45-ish now, join us again in about 5 hours and you will get to start exploring the deep sea with us.
Yeah, and I would just add Happy World Oceans Day. And World Oceans Day is also an important time to think about how we treat and interact with our oceans. Our oceans are an important resource for us. We wouldn't be alive, frankly, without them. And we rely on them for much of our food and more of our energy. But it requires active regulation. And even though it's so big, 71% of our planet, it definitely can be affected by human activity, is being affected by human activity. And it's something we need to be very conscious about long-term good stewardship and management and conservation of our oceans. And so I would encourage you all to learn more and get involved in what you think is the appropriate way to manage and interact with our oceans for generations to come.
Couldn't think of better answers to wrap up our Oceans Day celebration with you two. Thank you so much. Thank you to the entire EV Nautilus crew and Ocean Exploration Trust for the broadcast. And as you know, what we do to wrap up every program, I'm going to bring in Mr. McGill, room 9, Mr. Shaddis class to join me live and saying a huge thank you and farewell. YouTubers, goodbye. Have a wonderful day, everyone. Bye for now, guys. Thank you all